This is your review for your first exam, which is from the current book's chapter 1. So let's look at this section on linear equations, and it says find all real solutions, if any, for each equation. The first thing you want to notice is that you have fractions, so we're going to have to get rid of those, and there are no variables in a denominator, so we don't have any domain restrictions here. So let's put each term in parentheses the way I showed you. So here is the first term, the second term, don't forget that one, and then this is all one term. And now I need the LCD for 8 and 12, my two denominators, which is 24. So I'm going to first multiply every term, including that 2, by 24 over 1. So 8 goes into 24 3 times, and I'm left with 3 times 1 is 3 times 2x plus 5. Don't try to distribute that all in one step. Minus 24 times 2 is 48. Now we're going to stretch across here to cross cancel. 12 goes into 12 once. It goes into 24 2 times. So we're left with a 2 times a 3 minus x. Now we can go ahead and distribute, and we get 6x plus 15 minus 48 equals 6 minus 2x. Combining like terms on this side gives me 6x minus 33, a positive 15 and a negative 48. On this side, there are no like terms to combine. I'm going to get my variables together by adding the 2x. I get 8x minus 33 equals 6. Let's continue up here. So 8x minus 33 equals 6. I'm now going to add a 33 to both sides, and I get 8x equals 39. We divide by 8, and we get x equals 39 eighths. This is not a situation where you have to check, and in fact, unfortunately, in this case, checking is harder than doing it the original time. So sometimes the best way to check on one of these is just to go back and rework the problem and make sure you didn't make any sign errors. Looking at the next one, a couple things again should come to mind. We have fractions, so I'm going to have to multiply by an LCD, but also I have a variable in the denominator. So I have a domain restriction. What is it that x can't be? X cannot be 0 in this case. So I'm going to put each term in parentheses. My LCD is what I multiply by to get rid of all denominators. So it's going to require a 6 and an x. So I'm going to write, squeeze it in, 6x beside each term. X cross cancels x. 6 times 3 is 18. 3 goes into 6 twice. I have 1 times 2 is 2 times x is 2x. Equals, my 6's cross cancel, and I'm left with an x. I am now going to add a 2x to both sides to get variables on one side, numbers on the other, divide by 3, and I get x equals 6. And since that is not in my domain restriction, my answer is fine. You could plug that one in fairly easily and check it. That's an easy one. All right, let's look at a much more difficult problem where we have rational expressions that are equal to each other. And over here, you will see x can't equal. That's your domain restriction, your domain, your LCD, and your solution set. All right, before we even begin, we need to factor, make sure both denominators are factored so that we can see what we need in our LCD. So here, I can factor out a 2. And I'm left with 3x minus 1. So I'm going to actually do my LCD first. So what I need in my LCD is I need a 2, and I need a 3x minus 1, but I also need a 2x plus 3. From that LCD, I can easily find my domain restrictions. So I know that the 2 is fine, but these two need to each be set equal to 0. So 3x minus 1, If I set that equal to 0, I will find a domain restriction. So I add a 1 to both sides, 3x equals 1, and divide by 3. So I know one thing that x can't be is 1/3. Now I'm going to do the same thing for 2x plus 3. So 2x plus 3, set that equal to 0. And I get 2x equals -3, divide by 2. And I see that x can also not be -3/2. Now, once you have your domain restriction, you actually have your domain. So the domain is the set of all x such that x is not the things you just found. And this is how you write it. So x can't be -3/2 or 1/3. So these two go together, the restriction and the domain. Now we need to solve, and I think what I'm going to do is rewrite this so we have space, and I'm going to use the denominator, 12x minus 25, in its factored form, 3x minus 1. Now I'm going to use a different color so you can see what's going on. I'm going to put each term in parentheses, and I'm going to write my LCD. So 2 times 3x minus 1 times 2x plus 3 beside each term. In this case, we only have 2 terms. So 2 times 3x minus 1 times 2x plus 3. I just realized I left off a parentheses. Now let's see what cross cancels. 2x plus 3, 2x plus 3. What's left? Here, be careful how you write it, is a 2 times a 3x minus 1 times 4x minus 1. Here, my 2's cross cancel, those cross cancel. What's left? 2x plus 3 times 12x minus 25. Now, I'm going to make an assumption here, and I hope it's not too big of an assumption. I'm assuming you can FOIL. I'm assuming that you can FOIL these, so I'm not going to go through that process and take a bunch of time up going through FOILing. So we're going to have a 2 times, when you FOIL this, first, outside, inside, last, you're going to get 12x squared minus 7x plus 1. You need to FOIL that, maybe on scrap paper, make sure you can do it. Over here, when we FOIL this, we're going to get 24x squared minus 50x plus 36x, and then minus 75. Now I need to combine like terms here. So in my next step, I'm going to distribute that 2, and over here I'm going to combine like terms. Make sure you see where these all came from. So this is going to give me 24x squared minus 14x plus 2. And then on this side, when I combine like terms, I have 24x squared minus 50x plus 36x is minus 14x, and then minus 75. Now, you may already feel suspicious because of some things you see. But if I start out by subtracting to get everything equal to 0, a 24x squared from both sides, you're going to see it's going to zero out on both sides. And then if I add a 14x, you're going to see that that zeroes out on both sides. And what are you left with? You're left with 2 equals negative 75. Well, when is that true? That's never true. What does that mean? It means there is no solution. And the symbol for that is this. That is not a 0. That means the empty set. You could, I'm going to put or you could just write solution, no solution. So it wasn't because I got a solution that was in my domain restriction. It's because it's impossible. This is an impossible situation. There's no number that would work because of what we ended up with. So that was an unusual one. This next one has to do with solving a literal equation. We are wanting to solve for x. Here it is. So what I'm going to do is, because it's a negative term, I'm actually going to add the ax to both sides. That would give me a equals b plus ax, and now I'm going to subtract the b. That way I kept my term that contains my specified variable, I kept it positive. You could have, if you wanted, subtracted an a from both sides. I'll show you what that would look like. Now all that's left to do is divide by a, and I get x equals a minus b over a. Now let's say, I'm going to do it the other way. Instead, you had subtracted an a. You would have got negative ax equals b minus a. Now I would have divided by negative a, and this is awkward. Dividing by the negative changes the signs of that numerator. So you would have had a negative b plus a over positive a. But that's the same as a minus b over a. So you wouldn't want to leave your answer like this because it's not really simplified. Much easier to do it this way, keeping your specified variable term positive. All right, let's look at our next page. Here again, we are doing some specified variables. So it says solve a equals 1/2 hb plus b for little b. Got to get rid of that fraction first by multiplying by 2 over 1. And you have 2a equals h times b plus b. We now need to distribute to get rid of the parentheses. So 2a equals h little b plus h big B. We're trying to solve for this, so we want to get everything away from it. So 2a minus h big B equals h little b, and now the only thing left is to divide. And you get b equals 2a minus h big B over h. Those do not cross cancel because this is a unit. That was actually easier than the last one. All right, let's solve for c. In this case, I need to get the specified variable by itself, so I'm going to divide by m. Divide by m. I get e over m equals c squared. Now I need to take the square root of both sides, and I get, I'm going to turn this around, c equals square root of e over square root of m. Now think about why we're not finished here. Because I have a radical in the denominator, I have to rationalize that denominator, and that gives me c equals square root of em over these two multiplied together. Square root of m times square root of m is square root of m squared, which is just m. And so you have gotten rid of the radical in the denominator. All right, let's look at some quadratic equations. We're going to solve these by factoring using the zero factor property. So on the first one, to solve by factoring, I need to get it set equal to 0. So in order to do that, I'm going to add a 2 to both sides. So 3x squared plus 5x plus 2 equals 0. This is a long process factoring, so I'm looking for factors of positive 6 that combine to make positive 5. That's positive 3 and positive 2. So I do bring down, break down the middle term into those two pieces, bring down the last term. Now we group and factor out the GCF. GCF of the first binomial is 3x, and we are left with x plus 1. GCF of the second binomial is 2, and we're left with x plus 1. So my factors are x plus 1 times 3x plus 2 equals 0. Using the zero factor property, either x plus 1 equals 0 or 3x plus 2 equals 0. Here I subtract a 1, x equals negative 1. Here I subtract a 2 and divide by 3. So I have x equals negative 1 or x equals negative 2/3. Now, I didn't square anything to solve it, so I don't have to check it. There's no domain restriction because there's no variable in the denominator. So assuming I did the work correctly, this answer should be correct. In this next problem, we're asked to solve using the square root method. So the first thing you want to do is make sure that what has been squared has been isolated. And in this case, it has. So we're just going to take the square root of both sides. The square root of x minus 6 squared is x minus 6. The square root of 96 is plus or minus. Now I'm going to break this down. It has a perfect square factor. It's 16 times 6. So now I can pull this out, and I get x minus 6 equals plus or minus 4 radical 6. Now I just add a 6 to both sides, being very, very careful not to combine unlike terms. These are not alike. So it's just 6 plus or minus 4 radical 6. Don't forget your plus or minus. This one we want to solve using the quadratic formula. Factoring and quadratic formula are the two where you have to get it equal to 0. So I need to subtract a 4. That gives me x squared minus 6x minus 4 equals 0. I'm now going to designate my a, b, and c. I need to lift this up so you can see it. A is equal to 1. That is the coefficient on the squared term. B is negative 6. C is negative 4. The quadratic formula is the opposite of b plus or minus b squared minus 4ac all over 2a. Or x equals 6 plus or minus 36 plus 16 all over 2. X equals 6 plus or minus the square root of 52 all over 2. Now you may not realize that 52 has a perfect square factor, so it's 6 plus or minus 4 times 13. That's 52 all over 2. This comes out, and I'm running out of space, so let's scoot over here, and I have 6 plus or minus 2 radical 13 all over 2. At this point, you can cross cancel. If you can cross cancel, let me use a different color here, each term. So each of those 3 terms has something that will go into it, and that is 2. So I divide by 2, divide by 2, divide by 2, and I end up with 3 plus or minus radical 13, and it's over 1, so we don't need to show that. All right, let's look at the next page. This one is solved by completing the square. Now, when we complete the square, we isolate the x terms. So this 13 has to go to the other side. We have x squared minus 6x plus some magic number equals 13 plus the same magic number. This is an easy one because my middle term is even. So negative 6 divided by 2 is negative 3. Circle it and then square it. We add that to both sides. Now this, if you factor it, this is why I circled this, is going to be x minus 3 squared. That's the whole point. Equals 22. Take the square root of both sides, so now we're back to square root property, and I get x minus 3 equals plus or minus radical 22. That will not break down into perfect square factors, so all I have to do is add a 3, and I get x equals 3 plus or minus radical 22. That was a pretty easy one. Next one says solve by any method, factoring, completing the square, square root property, or quadratic formula, whichever method best fits the problem. Well, for this one, it's hard to tell because it hasn't been distributed, so let's do that. 4x squared minus 8x plus 3 equals 0. I'm always going to try to factor first because that is the easiest method if it's factorable. So this would be a long process. I would need factors of positive 12 that combine to make negative 8. That's easy. It's negative 6 and negative 2. So we break down that negative 8 into a negative 2x minus 6x and then plus 3. We're going to group. I see that negative in between, so I have to make the correction on the last term. GCF here is 2x times 2x minus 1. GCF here is 3 times 2x minus 1. So my factors are 2x minus 1 times 2x minus 3 equals 0. Using the zero factor property, either 2x minus 1 equals 0 or 2x minus 3 equals 0. I solve each of those and I get x equals 1/2, or here I get, divide by 2, x equals 3/2. So I have a 1/2 and a 3/2. I didn't square anything to solve that. So if I did the algebra correctly, which I did, I shouldn't have to check. Those are correct. The next one, find the dimensions of a rectangle. I'm going to first draw that. Length, width, whose perimeter is 28 meters and whose area is 48 square meters. So we have two formulas. P equals 2L plus 2W. That definitely has too many variables in it. And then I have A equals LW. So what I'm going to do is I'm going to fill in this one, the numbers that I know. The area is 48 equals LW. And I'm going to choose to solve this one for L. I could solve it for W, it doesn't matter. But I'm going to solve it for L by dividing both sides by W, and now I have this little L equals 48 over W, and I'm going to put that right there in the other formula. So I know that P is 28, so that would be, let's move it down, 28 equals 2, take out your L, put in your substitution, 48 over W plus 2W. 28 equals, go ahead and multiply that, 96 over W plus 2W. Now how do we deal with this? Well, I have a fraction. So we need to multiply every term, so let's put them in parentheses, every term by the LCD. And the LCD here is W. So I have 28W equals 96 plus 2W squared. The first thing I notice is those are all even numbers, so I can make my numbers smaller, and then I'm going to rearrange them. So let's divide by 2 to make the numbers smaller. So I can divide everything by 2. That's going to give me 14W equals 48 plus W squared. And now I just need to get it equal to 0. So W squared, subtract your 14W from both sides, minus 14W plus 48 equals 0. All I did was subtract a 14W from both sides and then just write it in order. This hopefully is a short process factoring, so I want factors of positive 48 that combine to make negative 14, negative 6, and negative 8. So W minus 6, W minus 8 equals 0. Set each one equal to 0, and I get that the width could be either 6 or 8. And it says find the dimensions. So if the width is 6, the length is 8. If the width is 8, the length is 6. How did I know that? Because together when you multiply them, you have to get 48. So it just depends on how you want to label length and width, and they would both be meters. All right, let's look at some complex numbers. It says evaluate the expression, and we've learned that the first thing that you always do is pull out the I. So we know that that is going to be equal to square root of 24I. Now we're going to break down this into its perfect square factor, which is 4 times 6. And then we have our I. Square root of 4 is 2, so I get 2 square roots of 6I. And that is the correct way to write it, with the I coming last. This one, I'm going to pull out the I, and it's going to be square root of 48I. Break down my 48 into 16 times 3. That's its perfect square factor. The square root of 16 is 4. That comes out, and we have 4 radical 3I. So again, the I comes last to be technically correct. All right, next page, it says solve each equation in the complex number system. Use whichever method works best for you and for the problem. Well, in this one, I see that I have something squared and it's isolated, so obviously we're going to take the square root of both sides. The square root of this is 3x minus 2. The square root of this is 8 I, and it's plus or minus. Don't forget that. Lots to think about when you have a negative square root. Don't forget the I, don't forget the plus or minus. Now I'm going to add a 2 to both sides. So I have 3x equals, remember these are not like terms, 2 plus or minus 8i, and now I just divide by 3 and I get x equals, now we're going to write this the correct way. So 2/3, so I'm splitting that, plus or minus 8/3 I. That's an A plus BI form. So you need to be able to go from here to here. So study that carefully how I did that. Looking at the next one, I'm going to choose complete the square. And the reason is there's a 1 here. It's not factorable. There's no factors of 41 that make -8. And this is an even number, so it makes sense to use complete the square. So I'm going to subtract a 41 from both sides. X squared minus 8x plus some magic number equals -41 plus the same magic number. -8 divided by 2 is -4, and -4 squared is 16. So that's my magic number. This side factors to x minus 4 squared. This side makes a -25. And now I'm right back to where I was in the one above. I'm now going to take the square root of both sides. So x minus 4 equals plus or minus 5i. Add my 4 and I have it. X equals 4 plus or minus 5i. That was a great way to solve it. It was the easiest way of all. I know you probably think quadratic formula is easier, but it's not. People make more mistakes with that one. All right, let's look at this one. These are radical equations and equations that are quadratic in form. So on this one, in order to get rid of the square root, I have to square both sides. That turns this left-hand side into just what was under the radical. On this side, don't forget to write it twice and FOIL it. It's x squared minus 4x plus 4. It's not just x squared plus 4. You have to write that twice and FOIL it. Now I want to get things equal to 0, and when I subtract my x squared, you can see what's going to happen. They zero out on both sides. So now I have 3 minus x equals -4x plus 4. This is just a linear equation. So I want to get variables on one side equal to numbers on the other. I am going to add a 4x. That gives me 3 plus 3x equals 4. I'm going to subtract a 3, and I get 3x equals 1. I divide by 3, and I get x equals 1/3. Now, because we squared, and this is an even root, it's a square root, we have to check it. This may or may not work. So I'm going to go back and put in 1/3. So this is the check. So I've got originally 3 minus 1/3 plus 1/3 squared is 1/9. Is that equal to 1/3 minus 2? So inside, to do this, I'm going to have an LCD. Remember, this is over 1. So it's going to be 27/9 times 9 times 9 minus 3/9 plus 1/9. Does that equal 1/3 minus, again, that has to have an LCD, 6 over 2. Oh, excuse me, over 3. My brain went too fast. So under the square root, 27 minus 3 is 24 plus 1 is 25/9. 1/3 minus 6/3 is -5/3. Does 5/3 equal -5/3? No. So my answer didn't work. So there's no solution for the empty set, whichever way you want to say it. No solution. On this next one, what we have is x to the fourth minus 10x squared plus 25. Now you may be bothered by that x to the fourth, but this is a perfect square trinomial. It's a simple short process trinomial, if you want to think of it that way, looking for factors of 25 that combine to make negative 10, negative 5, and negative 5. But it's not going to be x minus 5, x minus 5. It's going to be x squared minus 5 times x squared minus 5. Or x squared minus 5 squared. So now I can take the square root of both sides, and I get x squared minus 5 equals square root of 0 is 0. I now add 5 to both sides, and I get x squared equals 5, but we don't want x squared, we want x. So I have to take the square root again. And that gives me x equals plus or minus square root of 5. Do we have to check that? No, because we didn't square anything like we did up here. We did the opposite. We took the square root of that number, of that expression. All right, let's look at the next one. This next one is a perfect example of a U substitution because I have something here and the same something here squared. So we're going to say, let U equal 3x plus 4. So that would give me U squared minus 6U plus 9 equals 0. That is definitely factorable. It's U minus 3 times U minus 3 equals 0. So using the zero factor property, U minus 3 equals 0, U equals 3. But remember, we're not looking for U, we are looking for x. So if U is 3, then 3 is equal to 3x plus 4. And now I am going to solve that, and I get 3x equals negative 1. I divide by 3, and I get x equals negative 1/3 by back substituting. I don't need to worry about it not working. I didn't square anything. I just made a substitution. And there are no domain restrictions because there's no variable in a denominator. This one, there's a couple ways to do this one. What I'm going to do is when I see the square root, I want to get rid of it. So what I'm going to do is I'm going to add a 4x square root of x to both sides so that I have x equals 4x square root of x. And now to get rid of that, I'm going to square both sides. But remember, the whole thing's being squared. So that gives me x squared. Now over here, you got to be careful. The 4 gets squared. The x gets squared, but so does this. So that gives me another x. So I have x squared equals 16x cubed. So what I want to do now is I want to get it back equal to 0 by subtracting an x squared from both sides. So 16x cubed minus x squared, that was a subtract, equals 0. And we learned on this one to factor out what you can. So I'm going to factor out the x squared. I'm left with 16x minus 1 equals 0. And so what I have is I have a zero factor property situation. Either x squared equals 0, in which case square root of both sides would be x equals 0, or 16x minus 1 equals 0. And we solve that by dividing by 16, and I get or x equals 1/16. Now, I squared something to solve, so I have to check both of these. So let's check 0 first. Is 0 minus 4 times 0 square root of 0 equal to 0? Yes, definitely. So this works. That's an easy check. The next one's a little bit harder. Let's check 1/16. Is 1/16 minus 4 times 1/16 times square root of 1/16 equal to 0? That would be 1/16 minus, I can cross cancel here, 1/4. What is the square root of 1/16? It's 1/4, because 1/4 times 1/4 is 1/16. Is that equal to 0? Is 1/16 minus 1/16 equal to 0? Yes, it is. So in this case, they both work, but the check was difficult in this one. All right, let's go to inequalities. It says write the inequality using interval notation and then show it on a number line. And here it's showing me that x is between -2 and 0. It does not include the -2, but it does include the 0. So there it is in interval notation. On a number line, my two key numbers are -2 and 0. The 0 is included, -2 is not, and it's everything in between. So it would just look like that. Okay, write the interval as an inequality involving x and then illustrate using a number line. In this case, I think it's easier to do the number line and then to write the inequality. You may disagree, so I'm going to put this on a number line. If this is 0, 1, 2, there's my key number. It includes it, and where does it go down to? It goes down to -infinity. So what does that mean? It means that x is less than or equal to 2. And I honestly think it's harder to go this direction than it is to do the one above, where you already have the inequality and you go to the interval. So just think about what it means. On number 23, we have to solve the inequality. So I see x is here and x is here. We need to get those together. So I'm going to subtract x minus 2 greater than or equal to 3. I add a 2 to both sides, and I get x is greater than or equal to 5. So there's my inequality. It includes 5, greater than or equal to, so it goes up to infinity. I can write it as a set, the set of all x such that, and now I just write this, x is greater than or equal to 5. And then I can put it on a number line. It's an easy one. 0 as a reference point. 5 is my key number. Did I count right? 1, 2, 3, 4, 5. Yes. It includes 5 and it goes that direction. So that was a fairly simple one also. All right, on our next page, I have an inequality. My x's are in the middle and I have a fraction. So the first thing I have to do is get rid of the fraction by multiplying by the LCD. 0 is less than 3x plus 2. Now I wrote over my symbol so I can't see it anymore. Is less than 8. The x is in the middle, so I need to get everything away from it and keep it in the middle. So -2 is less than 3x is less than 6. I now divide everything by 3, and I get -2/3 is less than x is less than 6 divided by 3 is 2. So here it is as an inequality. As an interval, it's in between -2/3, notice it's a parentheses, it's not included, and 2, not included. So there it is as an interval. As a set, the set of all x such that, I just copy this, -2/3 is less than x is less than 2. And on a graph, if this is my 0, there's my 2, -1, -2/3 is about right here. It's not included, and it's everything in between. All right, let's look at this next one. This one's kind of odd. So in order to know what I have here, I'm going to have to FOIL those out. So when you FOIL this, you get a difference of squares. So x squared minus 1 is greater than. When you FOIL this out, you get x squared plus x minus 12. So I want to get my variables together, and if you notice what's going to happen to your squared terms, they're just going to be gone. So I have -1 is greater than x minus 12. So my x is on the right. We're going to get numbers on the left. So 11 is greater than x, and we talked about how that isn't a usable form, so we're going to turn it around. X is less than 11. There's the inequality. If I go straight to the number line, which would be what I did next, here's 0, here's 11. It doesn't include 11, and it goes all the way down to negative infinity, which gives me my interval to 11. And then in set notation, it's the set of all x such that x is less than 11. Remember, these two go together, and these two go together. All right, let's look at equations and inequalities that involve absolute value. And these are a little more difficult. So on the first one, we have absolute 3x is less than 15. And if we have a less than, that is a type 1. So we know that that means that I take the 3x out of the absolute value. I write the right-hand side the same, and the left-hand side is the negative of that. So all that's needed to do to solve this is divide by 3, and that gives me negative 5 is less than x is less than positive 5, or negative 5 to 5 in interval notation, and then on a number line, negative 5, 5, it's what is in between. Type 1s are always in between. All right, same thing here. My absolute value is isolated, so write it. Keep the right-hand side the same. Put the left-hand side with the negative. Now I need to subtract a 5 from all three pieces. Negative 12 is less than or equal to 2u is less than or equal to 2. I divide by 2, and I get negative 6 is less than or equal to u is less than or equal to 1, or negative 6 to 1. They are included because of the or equal. And remember, on the number line, just show the key numbers. Because it is a type 1, which is less than, it's everything in between, and they are included with brackets. On this last one, which is a type 1, less than, I have to isolate the absolute value by adding a 4 to both sides before you start taking anything out. That gives me this. Now I know what that means. It means 1 minus 2x is less than 3, and then go over here and put it less than, and then negative 3. So I'm going to subtract a 1. That gives me, whoops, you can't see. That gives me negative 4 is less than negative 2x is less than 2. We divide by negative 2, and we know dividing by a negative causes the sign to flip. So this is a positive 2, flip the sign, positive x, flip the sign, negative 1, and now the whole thing is backwards. So I have to rewrite it the other direction. So negative 1, change it back to the sign, x, change it back, and 2. So there is the inequality. Negative 1 is the interval not included. 2 is the interval not included. So there is the interval. On a number line, negative 1, 2, not included, everything in between, because they are type 1. All right, let's look at a type 2. It is more work. It is more difficult. I understand. What this means, take this out of absolute value since it is isolated, is that 3x plus 4 is less than or equal to negative 2, or 3x plus 4, keep the greater than, is greater than or equal to positive 2. Now I have to solve that. I subtract here, 3x is less than or equal to negative 6, divide by 3, x is less than or equal to negative 2. We'll deal with that in a minute. Here I subtract a 4, greater than, divide by 3, and I get x is greater than or equal to negative 2/3. Now, let's do the number line first, and then we'll do the interval. This is the one where the interval's hard. So if this is 0, -1, -2, here is -2/3. It's greater than or equal to that, so it's going that direction from that one, but it's less than or equal to -2, so it's going that direction on that one. So this is a type 2, and on a type 2, you've got the outsides, not the middle. So when I write my interval, it's got to look like this, my interval. So it goes -infinity to 2 includes union, because there's a big hole there, union -2/3 to +infinity. And this is the hardest part about a type 2, other than setting it up. All right, let's look at some application problems. And most of these are mixture. So it says the manager of a coffee shop has one type of coffee that sells for $5 a pound and another type that sells for $11. Before I go any further, I'm going to say, let X equal the amount at $5 and Y is the amount at $11. And I'm going to draw myself a little picture. All right, so an amount here plus an amount here. Now I can finish reading. The manager wishes to mix 90 pounds of the $11 coffee. Uh-oh, we already know how much that is. I know this is a 90, so we set up a problem and it's not quite right. We can go back and fix that. So I know that this is a 90. Okay, so I don't need to use a Y. I know what that is. He wants to mix 90 pounds of the $11 coffee to get a mixture that will sell for $10 a pound. So this one is 5, this one is 11, and I need to know how much of this. So what we need to know how to label is what is this, the total, because normally you're told the total. In this case, we are not told the total, we're told one of the amounts. So the total here is going to be this plus this. So that's what I write. And it turns out in this case, I don't need two equations. I know that 5 times x plus 11 times 90 is going to equal 10 times this total, which is 90 plus x. So this one's a little bit different. You really only have a value equation, and I can solve it because there's only one variable. So 5x plus 90 times 11 is 990 equals 10 times 90 is 900 plus 10x. I'm going to subtract to get my variables on the same side. I get 990 equals 900 plus 5x minus 900 equals 90. 5x, we divide by 5, and I get x equals 18 pounds of $5 coffee. So let's kind of look at this one again. There's a lesson to be learned here. What I did was perfectly fine, but as soon as you find out one of those numbers, it changes the whole thing. You really don't need to have two equations because I already know one of my amounts. It actually makes it easier. Okay, let's look at this one. The owners of a candy store want to sell for $6 a pound a mixture of chocolate-covered raisins, which usually sells for $3 per pound, and chocolate-covered macadamia nuts, which usually sells for $8 a pound. Now, this is confusing the way it's worded. So let's do what we did on the last one, and then it may change. So I'm going to say let x equal the amount of, now what are they mixing? Chocolate covered raisins. So they want, let's see, they want chocolate covered macadamia nuts and chocolate covered raisins together. So let x equal the amount of raisins, I'm not going to write chocolate covered, and y equal the amount of nuts. Now I'm going to do the same thing I did in the last one, and then we may have to change it. Let's see what we know. They want to sell a mixture of both, and they want to sell it at $6 a pound. So I know that's their goal, okay? And they're going to mix the raisins, that's X, which sell for 3, and the macadamia nuts, Y, which sell for 8. But let's look at what they tell us. They already have a 50-pound bag of the raisins. So what do I know? I know what this one is. I know that the raisins, which normally sell for $3 a pound, I know how much it is. So this is like the last one where I can take that X out because I know what it is. It's 50. And so the question is, how many pounds of the nuts do they need? So again, here in this total, what am I going to have? I'm going to have the 50 plus Y. So I don't need 2 equations. I only need the value equation. So I need 3 times 50 plus 8Y equals 6 times 50 plus Y. And now we need to solve that. So 150 plus 8Y equals, distribute 300 plus 6Y. We are going to get our variables together. 150 plus 2Y equals 300. Numbers on the other side, and I get 2Y equals 150. Divide by 2, and I get Y equals 75 pounds. So this was like the last one, where even though we had it set up, turns out we knew one of the numbers and you didn't need 2 equations. Okay, let's look at another one. One of these is going to work the way we set it up the first time. It says a chemist needs 120 milliliters of a 71% solution, but only has 55% and 79% solutions available. Okay, this is the kind we're used to. So let X equal the amount of 71% solution, Y equals the amount of 79% solution. There's my picture. So 0.71, Y 0.79, and what is he going to get? He's going to get 120, so this time I know that number. And he wants it, oops, I did something wrong. He wants the end one to be 71. So I labeled this incorrectly. So that one is one of the ones he has. He only has 55 and 79. So that should be your 55. You really have to read carefully, I'm saying to myself. Okay, so now what we need is we need an amount equation. That would be X plus Y equals 120. Or if I get that into a good form, it's going to be Y equals 120 minus X. That's going to be my substitution equation. How did I do that? I subtracted an X from both sides. I need a value equation. It's exactly the same as this. X plus Y equals 120, but it has the labels in front. So 0.55, 0.79, 0.71. Now what I'm going to do is substitute this into here. So 0.55x plus 0.79 times 120 minus x equals 0.71 times 120 is 85.2. Use your calculator. Or 0.55x plus, let's distribute this. That will be 94.8 minus 0.79x equals 85.2. I'm going to combine my two x terms. Negative 0.24 plus 94.8 equals 85.2. Subtract the 94.8 from both sides. I get negative 0.24. Oops, I forgot my x here. X equals negative 9.6. We divide by a negative 0.24. And you get X equals, in this case, 40 milliliters. Now, X was what? It was the 55%. How do I find Y? I use my substitution equation again, 120 minus X, or 80 milliliters of the 79% solution. So that's the kind you're more used to. All right, let's do another one. How many gallons of 30% alcohol solution must be mixed with 60 gallons of 14% to obtain a solution that is 20%? So this is like the other ones on the front or on the other page. So I'm going to say, let X equal the amount of 30%, but I don't need to say that Y is the amount of 14% because I know how much it is. So it's 60 equals the amount of 14%. So I'm still going to draw a picture because I think that's helpful. And I know that I'm mixing some amount that I don't know at 30% with an amount I do know at 14%, and I want to get an amount that is 20%. And how much is it going to be? It's going to be 60 plus X, or X plus 60. So in this case, I only need my value equation. So it's 0.30x plus 0.14 times 60 equals 0.20 times 60 plus x. Obviously, you can drop those zeros. So we have 0.3x plus 0.14 times 60 is 8.4. 0.2 times 60 is 12 plus 0.2 times x. Let's get the x's on the same side. So 0.1x plus 8.4 equals 12. Subtract the 8.4. You get 0.1x equals 3.6. Divide by 0.1 and we get x equals 36 gallons of the 30% solution. So you really have to read these carefully to see if what is missing is one of the amounts, or if you know one of the amounts and you have to combine the two amounts to give you the total. All right, how many liters of 80% hydrochloric acid must be mixed with 40% hydrochloric acid to get 15 liters of 65%? Okay, this is like this one. So we're going to say, let x equal the amount of 80%, and I can say y is going to be the amount of, what's the other one, 40%. So now let's draw this picture and we'll get our two equations. All right, so I'm mixing 0.8, that's its label. Here's its label. And what I'm going to get is I want to get 15 liters. So this has to be a 15, and we want it to be 0.65. So my amount equation is x plus y equals 15. Solve for y, or y equals 15 minus x. That becomes my substitution equation right there. And then my value equation is 0.8x plus 0.4y equals 0.65 times 15. Substitute 0.8x plus 0.4 times 15 minus x equals 0.65 times 15 is 9.75. Let's distribute. 0.8x plus, if you multiply this, you get 6, minus 0.4x equals 9.75. Combine like terms, 0.4x, and let's subtract the 6 from both sides. We can do that at the same time. Equals 3.75. Divide by 0.4. Now this doesn't go evenly, and it says round it to 3 decimals. So in your calculator, that should be real easy to do. You're going to get 9.375 liters of 80%, And then we have to know how much of 40%. It would be good if you could see this, wouldn't it? Sorry about that. Of 40%, it's going to be 15 minus 9.375, which is about 5.625 liters of 40%. So there are both kinds of mixture problems on here, and you need to be able to read them and determine, is it one where you just need the value equation, or is it one where you need the value and the amount equation because you don't know either one of the amounts versus you do know one of the amounts.